Hi again, everybody. Welcome back. We're going to be doing Grade 8 Mathematics of Open Up Resources. This is Unit 3, Lesson 2, Graphs of Proportional Relationships. Number 1 says, a tortoise and the hare are having a race. After the hare runs 16 miles, the tortoise has only run 4 miles. The relationship between the distance x the tortoise runs in every mile for y miles, and the hare runs is y equals 4x. Graph this relationship. Well, we know that because this fits our y equals kx relationship, that k is also equal to slope. So we can see this 4 as 4 over 1, which is our change in y over our change in x. And we can also see k is also helpful because it is our unit rate. So when x equals 1, y is also going to equal 4. So we're going to start here at the origin, and we know that when x is 1, y is equal to 4. Okay, so now we have our 2 points, and we can go ahead and graph them as a line to show our proportional relationship. Okay, so that's what it should look like. Number 2 says the table shows a proportional relationship between the weight on a spring and the distance the spring has stretched. Complete the table for A. Describe the scales you could use on the x and y axis of a coordinate grid that would show all the distances and weights of the table. Alright, so we've got 20 and 28 here for distance and weight. So that's our big clue as to how we can figure out the rest of them. Now we know also that if we multiply 20 times our constant of proportionality k, we're going to get to 28. So if we divide y from x here, we'll get our constant of proportionality. So 28, which is our y, and this is our x, 28 divided by 20 is going to equal 1.4. So that's going to be our constant of proportionality, is 1.4. Now we can take 55 times 1.4, and that gets us to 77. 140, since we're going the other way, we have to divide by 1.4. So divide by 1.4, and that's going to give us 100. Makes sense. And 1, obviously, times 1.4 is going to be 1.4. Okay. So now it says describe the scales you could use in the x and y axis of a coordinate grid that would show all the distances and weights in the table. If we want to, what we could do with this one is we could use the horizontal. We could say, let's just make a quick graph here and sketch it out. So if this is distance, we could go from 0 all the way up to 100, and that would be our maximum, so we would be fine there. And then our weight goes up to 140. So we could start here at 0, and then we could go up to, let me put weight here. Our weight was measured in newtons, and our distance was measured in centimeters. So this one could go from here up to 140. I'll just put 150 because it's a nice round number. So those are scales. We'll be able to see all of our weights on there. Okay, number 3. Alright, number 3 goes back to Unit 2, and we're looking at a rigid transformation that goes from, transformation that goes from figure E, B, C, D to E prime, B prime, C prime, and D prime. And how can we use translations, reflections, and rotations in order to prove that these shapes are similar to the other. Alright, well the first thing I'm going to do is I'm going to say they look visually like they could be similar. So that's one way that I could do it. Now the other way that I'm going to do it is to say that this figure looks like it's been dilated with a scale factor between 0 and 1. Because when we know that when our scale factor is between 0 and 1, it's going to be a reduction. Okay? Alright, so if I look here from A to D double prime, that's 1 unit. How far is it from here? It's 1, 2, 3 units. So that tells me that the scale factor is probably 1/3. Let me double check. So I've got 1, 2, and then this would be 1, 2, 3, 4, 5, 6. So 2 to 6 is 1/3. And then B is 1, 2, 3, 4, 5, 6, 7, 8, 9. So then this should be 3. 1, 2, 3. It is good. And last one to check is C. 1, 2, 3, 4, 5, 6, and this is 1, 2. So okay, so we know that our scale factor is 1/3. Okay, so if we shrink this by a scale factor of 1/3, so 1, dilate E, B, C, D by scale factor of 1/3 with center of dilation A. That'll be our first one. It'll shrink it down to the right size. Okay, now what I know also though is that I'm going to have to reflect it because the D is here and E is there, so I'm going to need to kind of reflect it over this. Now if I shrink it down, let's see where this one's going to wind up. I'm going to go 1, 2, 3, 4, 5, 6. So this will be 1, 2, it'll be here. And then D will be 1, 2, 3 units, so it'll come down to here. So this is going to be my new ED. And then B goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 3 units, 1, 2, 3 away. And this is going to be 1, 2, 3, 4, 5, 6. So that'll be 2 units away. Alright, so that'll be what it'll look like after I dilate it with a scale factor of 1/3. Okay. So now I'm going to sketch a line in here. This line right there. I see that this is 1 away. And then right there, opposite that. And I'm going to call this line L. And then number 2 will be reflect E, B, C, D, and we'll call these primes, over line L. And that'll get me right on top of there, which will prove that those two figures are similar. Okay, number 4 says consider the following dialogue. Andre said, I found out 2 figures are congruent, so they can't be similar. Diego said, no, they are similar. The scale factor is 1. Who's correct? Use the definition of similarity to explain your answer. Okay, well, we know that by the definition of similarity that the shapes can be congruent. Even though if the scale factor is 1, that means that they're the same size and the same shape. So they have the same angles and the same side lengths if the scale factor is 1, which also means they're congruent. So because similar shapes can be congruent, I agree with Diego. Okay. That was, again, Unit 3, Lesson 2, using graphs and proportional relationships of Grade 8 Mathematics for Open Up Resources. As always, keep learning, keep making mistakes.